Okay, this is the Unit 8, Lesson 4, Part 2. So again, we talked about rhombuses last lesson. This time we're going to be talking about the rectangle. So again, we'll dig into like the different properties, but as you can see, they can look different depending on their dimensions. So a rectangle is a parallelogram that has 4 right angles. So again, that's the key factor of a rectangle is that it has 4 right angles. So again, you can see these right angles are denoted in the corners with the boxes. And so because of that, or another property of the rectangles is that their diagonals, which again go from one vertex to the opposite vertex, are congruent, which means exactly the same. So rectangles have 4 90-degree angles. Their diagonals are congruent. So we can use this to help us, figure out missing information. If we take a look at this example, we have the diagonals of a rectangle, QRST, intersect at P, given that, and we've got the angle PTS is 34 degrees. And then QS, again, I always recommend you fill in as much as you know. Q to S all the way down here is 10. Find the indicated measures. So let's find angle SRT. Okay. As I look at the top lines here, if we remember from way back when, if I were to extend these lines, this looks like 2 parallel lines cut by a transversal. So if we said that QR was parallel, that's an arrow. QR is parallel with TS. Then I could say that, hey, I have something called, like if I draw it over here, 2 lines cut by a transversal, I could have something like alternate interior angles. So if I were to apply that thinking, again, this is AIA. This is review from way back earlier in semester 1. Alternate interior angles are congruent. So that means that this angle over here is also going to be this angle here. Now that kind of helps me, but that's not necessarily what the question was asking. The question we were trying to solve is what's angle SRT? This angle inside here. So what I can do is I can say, hey, my whole angle, that whole big angle is 90 degrees. And I can do little angle plus little angle equals big angle to figure out what that other missing angle is. So if I take away 34 from both sides, I'm going to get 56 equals X. So this would be 56 degrees, or not percent, 56 degrees right there. There's a few ways to go about getting the measure of angle QPR. Again, one of my biggest recommendations that I can give you is to pull out these triangles and work on them separately. So I'm going to pull this triangle out. I'm going to draw it over here. I'm going to fill in what I know. QPR. This we found was 34 degrees. We are trying to find angle R. But I do know that because the whole diagonal Q to S was 10, that halfway from 10 is 5. So I know that this angle is going to be 5. And this angle is also, or this line is also going to be 5. So because I have 2 lines that are the same, this means it's an isosceles triangle, which means that my angles are also going to be the same. So this angle over here is also 34 degrees. So I've used 34 twice. And I know that triangles always have 180 degrees. So we are left with angle QPR being 112 degrees. So again, to recap, what did I do? I pulled up the triangle QPR, I filled in what I know, and because the diagonal was 10, I knew that each of the sides of my triangle was going to be 5. So again, that kind of helps us right here. RP is 5. RS is a bit of a tricky one. And so when we look at RS, again, that's going to be this side right here. And what I want to do, or what I need to do, is find a right angle so that I can use trig. So I know that this corner is a right angle. Let's mark it up here, right here. So I'm actually, in order to use RS, I'm going to use RS, TS, and RT to create a triangle. So I'm going to sketch that out. And again, I always recommend you sketch it out. So here's my triangle, half of my rectangle. I've got a right angle here. I've already figured out that this is 56 here, 34 here, and then it's given to me that QS is 10, but diagonals are congruent. So if QS is 10, then TR is also 10. And again, what's my goal? What's my objective? To find RS. So I'm going to go ahead and use trig, and I'm going to use angle T to start. So I'm going to say, okay, from here, opposite, hypotenuse, and adjacent. I'm going to use opposite and hypotenuse. So that is sine of 34 equals, let's call it x over 10. So again, to get it by itself, 10 sine 34 equals x. X is really RS. Let's plug it into our calculator. 10 sine 34, we get 5.59. And let's double check it. Let's do from our other angle. Let's go from here, and again, this becomes adjacent, this becomes opposite, hypotenuse stays the same. And this time I'm going to use cosine. So cosine of 56 equals x over 10. 10 cosine 56 equals x. When I plug that in, 5.59. So I was able to get the same answer twice. So again, what does RS equal? 5.59. Last thing, just wanted to draw this up for you. So again, if we have our parallelogram right here, and then underneath that family, you can have a rhombus, which again has all four sides being the same. Maybe we do a different color. Again, these ones are equal, these ones are equal, and they're parallel. And then you can also have a rectangle, which has 4 90-degree angles.